This is the second video in our series of properties of exponents. We've already had one video on the division property. In this video, we're going to be focusing on the multiplication property. So do be sure to watch the division property if you have any questions about the property of division or turning things into a positive exponent from a negative. As we look at our multiplication property, we start with a simple example where you have x to the third times x squared. That's going to be equal to x times x, which is x cubed, and then you're multiplying that by x times x, which is equal to x squared. And as you can see, what you have is you have 5 different x's being multiplied by each other, which is why your final answer is x to the 5th. So as we use our property of multiplication, what that means is that if you had x to the third times x squared, that'd be x to the 3 plus 2 in that exponent, which is equal to x to the 5th. Of course, that's over 1, but we don't expect you to write that. So that's just all it is you're going to simply add those exponents as long as the bases are the same. So as we look at our second example, you have x to the 7th times x to the 4th. Obviously, you don't want to spend the time writing out 7 x's and then 4 x's. We know that there's going to be a total of 11 x's, so by using our property, we know that you have x to the 7 plus 4 by using that property, which is then x to the 11th, and that's all there is to it. For our third example, we have x to the 10 times x to the 0, which is kind of an interesting one because you have x to the 0. But if we just followed through on our property, you would have x to the 10 plus 0, which of course would still be just x to the 10th, which should allow for further clarification as to why x to the 0 is equal to 1, because then you'd have x to the 10th times 1, which is still your x to the 10th. In this example, we mix in multiple variables. You have x here, which would be x to the 1st, and then you have y to the 13th times x to the 11th times y to the 3rd. Now, it doesn't matter if these multiplication symbols were sitting there or not, or if it was all just smushed right next to each other, we would always be multiplying. And so you multiply the things that have the same base only. So by using our property, we would then have x to the 1st, and then plus 11, and then you'd multiply that by y to the 13 plus 3, which would be equal to x to the 12th times y to the 16th. Notice you don't need to put the multiplication symbol here. They're different bases. If they're all right next to each other, that implies multiplication. Our final example, you see that you have an x to the negative 9th in there. And if you looked at our previous video with the division property, you would know that you could move this down to the bottom and make that over x to the 9th instead. However, we're not going to do that problem this way because that was a division. This is the multiplication property. So we can see that we're all multiplying, so you're going to multiply things with the same base. So using your property, that would be x to the 20th minus 9 when you add a negative 9, and then you'd just be multiplying by y to the 5th. And so your final answer would be x to the 11th and y to the 5th. So even if we had rewritten this x to the negative 9th and brought it to the bottom, you would reduce those. Here you didn't have to because you